Hey guys, what's up? Moon Math Tutor here, and welcome to the third video in our quadratic series. If you haven't seen the previous videos, I'd recommend watching them before watching this one, because today we will be upping our factoring game. We will learn how to factor quadratics when the leading coefficient is not equal to 1. We will learn how to spot special patterns, and overall, we will learn how to factor fast without getting stuck. So with that, let's get started. So first, we're going to start with factoring quadratics when the leading coefficient is not equal to 1. So here, the leading coefficient is 2, and this is going to be similar to the method that we've looked at before in the last video. So first, I'm going to write down the steps. First, you would multiply A times C to get AC. Then second, you'll find two numbers that add to AC and two numbers that add to B. Sorry, I meant to say multiply to AC and two numbers that add to B. And then for the third thing, we're going to split up the middle term. And then for the fourth thing, we're just going to factor. Okay, so I'll show you what all of these mean. So first we're going to do A times C, and this is going to be 2 times 3 equals 6. And now we have to find two numbers that add to 6 and two numbers that are, sorry, two numbers that multiply to 6 and two numbers that add to 7. And this is just going to be 1 and 6. And now we're going to split the middle term. So what that means is, watch very closely what I do. We do 2x squared plus x plus 6x plus 3. And now we factor this thoroughly. So how we do that is we factor by grouping. We group together terms that share a common factor. So 2x squared plus 6x and plus x plus 3. And then here, I can just move this off to the side. I can factor out 2x from the first group to get x plus 3. And then I just have x plus 3 here. And then from here, we can factor out x plus 3 from the whole thing to get 2x plus 1. So this might be a bit awkward if you aren't really used to factoring by grouping, and this method will definitely take some practice to learn. Okay, so now we're going to start moving into like clever factorizations. So first we're going to start with the difference of squares, which is just a squared minus b squared equals a minus b times a plus b. So now the special factorizations we're looking towards, these ones are going to deal with like, you're just going to see like these patterns throughout math, and it's just best to like know them well. And in the case of like factoring and stuff, this stuff can really help you like factor a lot faster, which is really useful for like competition math, or just in case you're like interested in just learning more. So we're going to look at an example. So x squared minus 9 and 4x squared minus 25. So the way we usually approach these problems is we sort of see, okay, um, we have a perfect square here and a perfect square here, and so we can recognize this difference of squares pattern, and then we just rewrite it as x minus 3 times x plus 3. Now for here, we can also notice that these two are perfect squares, 2x and 5, and so we can just go like this. So overall, this should be like pretty simple, and generally if you get more practice with like seeing this pattern, you'll be able to identify it like pretty easily. So moving on, so now we're just going to cover two basic patterns that we're going to see a decent bit of the time, similar to the one from the previous slide. Okay, so this is how like these two goes. If you ever get confused with any of these, you can just have a plus b squared and just FOIL this one out, and you will end up with this. And same thing with this one. So now two examples for this one are going to be x squared plus 6x plus 9 and 9x squared minus 12x plus 4. So now this pattern is generally harder to spot than the one that we just covered for different squares. However, If you're interested in like memorizing this stuff, it can obviously help you save like a lot of time. So here we can start by noticing that this is just this one is x squared, this one is 2 times 3 times x, and this one is just going to be 3 squared. So now what we can do here is we can rewrite this whole thing as x plus 3 squared because it follows our pattern of a squared plus 2ab plus b squared. And now same process for this one. This can be written as 3x squared, and this is minus 2 times 3x times 4 or times 2, and this right here is just 2 squared. And this can be written as 3x plus 2 squared. I meant to say minus because we have a minus 2. Okay, there we go. So now let's just do a bit of quick practice. So I'm going to write these out first, and then I'll give you time to solve them. And these are going to be 3x squared plus 10x plus 3, x squared minus 16, and 9x squared minus 6x plus 1. Okay, so I will count down to 5, and once I count down, I will start by working through these. So feel free to pause the video and work through these examples first and compare them to my answers. 5, 4, 3, 2, 1. Okay, so this first one, I don't really see any special factorizing like patterns, so I'm just going to go for the AC method. So I get AC is equal to 3 times 3, which is 9, and B is equal to 10. So two numbers that multiply to 9 and add to 10, well, that's just going to be 1 and 9. So I'm going to split the middle term of this thing, which should give me 3x squared plus 9x plus x plus 3. And here I'm going to group together like terms. And factoring this one out should give me and we get x plus 3, 3x plus 1. Okay, now the second one, let's do it in a different color. X squared minus 16. So this is just x squared minus 4 squared, which is basically a difference of squares. So notice how this, just knowing difference of squares, saved me a lot of time on this one. Okay, now finally for the last one. Let's do this in green. Okay, so this one, I'm gonna see that this is 3x squared. This is gonna be minus 2 times 3x times 1, and this is gonna be 1 squared. So I can recognize the pattern that we just covered, which is going to be 3x minus 1 squared. And once again, even though we could have used the AC method for this one too, just knowing this factorization saved me so much time. So yeah, now hopefully you have like a full toolbox for factoring almost any quadratic. Next time we will take these factored forms and use them to solve like quadratic equations, including some that aren't factorable. So in the next upcoming videos, we're going to cover methods that deal with how to factor quadratics that aren't exactly factorable, such as the quadratic formula and other stuff. So if you thought this video was helpful, feel free to drop a like and make sure you subscribe for more math tips. See you guys next time.